Right, hello. So I'm just going to quickly go through all the homework. So hope you were able to do it. Most of it is fairly self-intuitive. So the first one is, what have we got here? A normal distribution has a mean, has a mu of 60. It's question 4. Pair 1 has a mu of 60 and a standard deviation and a sigma, I'm never going to draw on that, of 5. Find the range in which 68% of the distribution lies. Okay, so let's think about it for a second. So 68 distribution is one standard deviation either side. Okay, so it's plus or minus 1. So it's plus or minus 1 standard deviation either side. So let me see. Let's see what Z score, that's the Z score we're looking for. So let's see what possible X is going to give me that. So remember, this is our Z formula. So we already have this Z score because it's plus or minus 1. That's one standard deviation either side. That's what it is as a Z score. So let's have a look at it. Let's see, let's cross multiply. So it's plus or minus 5 is equal to X minus 60. So if we take the plus version, then X is either going to be 55 or it's going to be 65. So my range of values for 68%, so 68%, where is it here? Yeah, 68% is going to lie within a range where X is less than 65 but greater than 55. Okay, so that's that one done. Okay, so the next one then, 95, it's the same thing again but with the 95. Okay, so 95 is, was it, plus or minus 2 standard deviations is away. Plus or minus 2 is equal to X minus 60 over 5. So that's going to be, what is it, plus or minus 10, 70. X would be 70, 10, or X would be 50. So 95% range is going to be X less than 70, but greater than 50. Okay, so that's question 4 done. So hope that makes sense. Yeah, right. Question 6 was the next one. Question 6. So question 6 is a little bit more the mean time it takes a factory worker to get to work. So we have a mu of 35 minutes. The times can be modeled by a normal distribution with a standard deviation of 6 minutes. What percentage of workers will take between 23 and 47 minutes? So that's what we're looking at here. What percentage of workers will take longer than 47 minutes? And is there, if there are 600 factory workers, how many will take between that amount? Okay, so why 23 and 47? Okay, so if you look at it very carefully, 23 is, what is it? It is 12 minutes less than the mean. In other words, it's 2 standard deviations less. Okay, so have a look at it here. I'll visually show it you. There's the mean. Take away 23 and you've got 12. And 12 is 2 standard deviations. So here's the mean again. Or sorry, here's the other number. And this is going to be 12 as well. So one is 12 below, one is 12 above. So you can see where this is going. Okay, so both of them are 2 standard deviations, but one of them is above the mean and one of them is below the mean. So this is where we're getting it. So we're getting our 95%, aren't we? So that means that 95% of workers take between 23 to 47 minutes. Simple enough. Okay, so that's the first one done. What percentage of workers take that time? That's the first bit done. The second bit, what percentage of workers are beyond that? Okay, well, 95%, if you think about it, let's just draw it here. That's 95% all in there. So at this end, we have 2.5%. And then here at 47 minutes beyond there's another 2.5%. So 2.5% of workers are above 47 minutes. Okay. And part 3 then, if there are 600 workers and we're at 95%, then we're talking about what? 570 workers. Take between what is it, 23 and 47 minutes to get to work. Now, that's question 6 done. So it's a nice one, I suppose, not the worst one in the world. Okay, so question 8. So question 8's a little bit tougher. Okay, so if you read it very carefully, question 8 asks us to test balls. They're dropped from a given height, and the height can rebound is measured. So you drop the ball, it bounces up. So it's a bouncy test. The balls that rebound less than 128, so if it's less than 128, you reject the ball. Assuming that the rebound height can be modeled by a normal distribution with a mean of 134 and a standard deviation of 3, find out how many tennis balls a batch of 1,000 will. Okay, so what we need to figure out is how many of the 1,000 balls will fall into this range, assuming a normal distribution. Okay, so obviously it's not going to be that many because, you know, you're not talking about a lot. Okay, but we need to figure out how far down. So let's just have a look. 128 and 134. Okay, 134, 128. Surprise, surprise, that's 6. That's a difference of 6. Okay, so that's really 2 standard deviations. We're talking about 2 standard deviations, 2 sigmas. Okay, so that's what we're kind of dealing with here, 2 sigmas. Okay, so 128 is definitely less than 134. Okay, so what we're looking at is if you look at the kind of picture again, I hate drawing these all the time, but I think they really help. We definitely know everyone on this side is going to be accepted because 134, that's this way, up that way. Okay, so there's 1 standard deviation, so we're also going to accept all them, and we're all going to accept everything apart from that little sliver down here. Okay, so that's the little sliver we're not going to accept it. We're accepting all of these 2, that one, and that one, and the one up here. So remember, this whole thing equates to 100%. So the only sliver that's left down here is 2.5%. Okay, because we're including the other 2.5% here. Okay, so it's 2.5%. We're going to reject 1,000, which is, give me a second here, 25 balls. Well, that's a small rejection rate, I personally think. Okay, it's a pretty small rate to reject. All right, question 10. So, question 10. Let me just get it on this page here. Oh, this is an easy one. Use the normal. Okay, we got a mu. Okay, so we've got a mu is 80 and sigma is 4. We're going to use our Z formula to produce some Z scores. X minus mu over sigma. Okay, so for number 1, we're going to have 84 minus 80 over 4. For number 2, we're going to have 72 minus 80 over 4. For number 3, we're going to have 86 minus 80 over 4. And for number 4, we're going to have 70 minus 80 over 4. Equals, 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 equals. So get out the old calculator. Give me a second here now to do these on the old calculator. I left it in school, of course. So I'm using, very naughty, I'm using my phone to do these. But that's going to be 1. That's going to be minus 2, I think. 1.5, 6 over 4. Yeah, 1.5. And this is going to be minus 10 over 4. So 10 divided by 4. That's minus 2.5. So there's your z-scores. Okay, so hope that's just a nice little introduction to how to generate z-scores. Okay, so we've already kind of established that there is a link between them, the z-score and the standard deviation when you look at the original diagram. All right, so that's question 10. Right, next one I'd asked you to do was question 14. So let's have a quick gander at 14 then. Oh, poor Anna and her maths and history. She got a mean and a standard deviation. So Anna, let's find her z-score for each subject. So for history, okay, so it's going to be 80 minus 75 over 12. That's for history. And for math, sorry, I've done that the wrong way. That's math. History, it's going to be 70 minus 78 over 10. So let's do her math. It doesn't look like a nice number, but anyway, let's do it. That's going to be 5 over 12. 5 divided by 12 equals, so her z-score for math is going to be 0.417. I'll just round it. And her z-score for history is going to be minus 0.8. So, part 2, which subject you should perform better? Part 2, math, as it has a higher z-score. Okay, and part 3, and Anna's friend Kira got a z-score of 0.5 in history. So she got 0.5 is equal to history x minus 7.78 over 10. So that means she got 83%. Or raw score. Yeah, we won't call it percent. She's got 83 marks, okay? We're not going to call it an actual score because I'm not sure what it was. Okay? Sorry. That I keep looking down at the book. So, z-score for maths, z-score for history. Maths is bigger than history, hence she did better in maths. Kira got a z-score of 0.5. Make that equal to what her mark was minus the mean divided by the standard deviation for history. Rearrange, solve for x, you get 83. So there you go. 14. Right. Question 16. Right. This one looks a little bit more interesting. So it does, as a question. So, the mean and standard deviation of 2 French papers are shown below. Paper 1 is a mean of 45, standard deviation of 8. Paper 2, mean of 56, standard deviation of 12. Sarah was present for paper 1 but absent for paper 2. In paper 1, she scored 59 marks. What's her z-score for paper 1? Okay, so her z-score for paper 1 is equal to 59 minus 45 over 8. Okay, so that's 14 over 8, I think. Let me just double check. Get the calculator out here. Right, so 59 minus 45 divided by 8, 1.75. Quite a healthy z-score. Okay, so that's her paper 1 z-score. Sarah expected to do equally well on paper 2. So on paper 2, we already have the z-score. She's going to get the same z-score on paper 2. Let's see, it's some number minus the mean divided by 12. Okay, so let's rearrange that. She should have gotten 77 if she wanted to maintain her mark. And good luck to her there, because that's very good going there, Sarah. Now, the last question, question 18. Okay. So, as part of her geography fieldwork, Alison is measuring and comparing the lengths of pebbles on 2 beaches. On the first beach, the mean, let's take beach 1, the mean is 8 and sigma is 1.4. On beach 2, the mean is 9 and sigma is 0.8. She finds a pebble of length 10 millimeters on each beach. She claims that this is less likely to happen on the first speech. Use standardized scores to test her claim. Right, so this is the important bit. She finds a pebble of 10 millimeters on each beach. Okay? So she's claiming that this is less likely to happen on beach 1. So let's just work it out. Okay? So 10, let's go with beach 1. 10 minus 8 over, what is it, 1.4. Let's get the z-score for that. 10 minus 8 is 2. 2 over 1.4 is, I'm trying to think, 2 divided by 1.43. Right, let's test it for B. Okay, what have we got here? We've got 10 minus 9 over 0.8. So that's 1 divided by 0.8. That's 1.25. So she is right. Okay, it is less likely. Ali is correct. It is less likely to happen on the first speech. She is correct. Right. Thank you very much, lads. Okay, you have your work for today. Best of luck with it.